Dear students, today we'll see what do we mean by CMOS. CMOS means complementary metal oxide semiconductor. Complementary MOSFETs. Okay, complementary MOSFETs means one MOSFET should be P channel type MOSFET, PMOS, and other one should be N channel type MOSFET, that is NMOS. If you take two different types of MOSFET and put it on the same substrate, then it will be called as complementary MOS. Okay, so one you have to have P channel MOSFET and one you have to have N channel MOSFET, and both you have to connect and put on a same substrate, same connection over there, and then it is called as complementary metal oxide semiconductor. As an example for this, we can study what is a CMOS inverter. Okay, so here you can see circuit diagram of CMOS inverter. Now here you are having your MOSFET, enhancement type MOSFET, okay, which is P channel. The arrow is shown outside. Okay, so this is a P channel enhancement type MOSFET. And here you can see one more MOSFET. The arrow is inside. Okay, this is N channel enhancement type MOSFET. Okay, now the drains of both the MOSFETs are connected here. Drain of this MOSFET and drain of this MOSFET connected here and taken as output. This is the output. Similarly, the gate of both are taken together and given as one input. The source of P channel is given to plus 5 volt and the source of N channel is given to ground. This is ground. Okay. Now, if the input is say high voltage, if the input is high means positive, then here if you see the capacitance effect, if the input is positive, okay, automatically the other side of the semiconductor will become negative, and that negativity will reduce the P channel and this FET will become off. There will be no current flowing from source to drain, and therefore this channel will be off. Now same positive voltage goes here. If this is positive, okay, and then the semiconductor part will become more negative, enhanced negative, and you get more electrons to make a channel between source and drain, and more current starts flowing. That means the N channel MOSFET will become on. So if input is high, okay, N channel will become on and P channel will become off. If he is off and he is on, that means ground is connected to the drain and the output will be ground. Ground is low. That means when the input is high, the output is low. Okay, this is a combination of inverter input and output. Okay. Similarly, if you take input as low, some minus voltage. Okay, then this part will be minus and this part will be plus because of your capacitance effect. And because it is plus, it will enhance the number of volts and there will be more current flowing from source to drain. So Q1 will become on. So when input is low, Q1, that is P channel, will become on. This will become on. Similarly, low voltage you are going to give here. This is minus. This side will become plus. Once this side becomes plus, so it is depleting the electrons. So there is no channel between source and drain and no current flows. This is off. So N channel will become off. So he is off and Q1 is on. When Q1 is on, the source of plus 5 volt is connected to the output. Output becomes high. That means when input is low, output is high. When input is high, output is low. This is a inverting action. So this kind of circuit can work as a CMOS inverter. Now basic thing what over here is, we have used one P channel MOSFET and one N channel MOSFET. PMOS and NMOS on the same substrate, so it is called as CMOS. Okay, and because simultaneously both the FETs will not get on, only one will be on at one time, there will be very less current flowing. There will be very less current flowing. So magnitude of current is less, magnitude of power consumption is less. So that becomes a very important advantage of CMOS, that magnitude of power consumption is less. And also it adds on another advantage, that it has high packing density, which can help you in very large scale integration of integrated circuits.